Our next theorem is fundamental theorem part 1. And first see the equation fx is equal to integral from a to x f of t dt. Now fx gives us area under the curve ft from x equal to a to any value of x. So this gives us area as a function of x. Okay, now what if we need to differentiate this function given in equation number 1? So by definition of derivative, this is the derivative of this function is f of x plus h minus f of x over h as h approaches to 0. Now what does f of x plus h means? Now we have a point x, we have a point x plus h, where h is very small. Now fx is the area under the curve from x equal to a to this value of x. So that is f uppercase fx is this area in blue shade, where uppercase f of x plus h is the area under the curve up till x plus h. Now difference between f of x plus h and f of x is this small rectangle, purplish colored rectangle. Now when h approaches to 0, so x plus h approaches to x. So this means derivative of uppercase f, that is derivative of this integral, is equal to the value of fx. So this is called fundamental theorem of calculus, integral calculus part 1, and this is stated on page number 280. And the statement of the theorem is, if f is continuous on closed interval ab, then fx is equal to integral from a to x ft dt is continuous on closed interval ab and differentiable on open interval ab, and its derivative is defined by this formula. And we have already seen its geometry that it makes sense. Now using this theorem we are going to solve these questions or evaluate the derivative of these integrals given in example number 2. First integral is y is equal to integral from a to x t cube plus 1 dt. Now the derivative of y, that is derivative of this integral, is dy by dx, which is equal to d by dx of a to x t cube plus 1 dt, and according to fundamental theorem this is equal to fx. Now ft here is t cube plus 1, so fx is x cube plus 1. So next part, y is equal to integral from x to 5 3t sin t dt. Now dy by dt is equal to d by dx of x to 5. Now we just learned the formula from a to x, integral from a to x. So in order to convert into that form, we interchange the upper and lower limit, and this adds the negative sign. So dy by dx of negative of 5 to x 3t sin t. Now in this case, function of t, that is ft, is equal to 3t sin t. So its derivative must be equal to 3x sin x. Now this negative sign is as it is. So the dy by dx is equal to minus 3x sin x. Next, y is equal to 1 to x square cos t. So y is equal to 1 to x square. Now in order to make it a variable rather than power of a variable, we make a substitution. So the upper limit of integration is x square. So let x square be equal to u. Now if x is equal to u, then we have to use the chain rule. Then dy by dx is dy by du into du by dx. and that is d by du of this, because y is equal to this, into du by dx. So according to fundamental theorem of calculus, this becomes cos u into du by dx. Now u is x square, so du by dx is 2x. So 2x cos x square. Similarly, we can solve part t, and part d is integral from 1 plus 3x square to 4 of 1 over 2 plus t dt. Again, what we need to do, we'll use chain rules directly rather than making substitution. Now we know what to do. We'll use this chain rule. Now first of all, differentiate this integral from 4 to 1 plus 3x square. You can make a substitution. 1 plus 3x square is equal to u, and use this chain rule by substitution, and you will get this result. I'll urge you to do it yourself.